Hello, I bet you've asked yourself the following questions before. Why does the sea move the way it does? How does sound travel throughout our environment? And even, why does light even exist? And why are there so many colors? Well, the answer to all of those questions might just be waves. And today I'm going to explain what waves are, how they work, and the different types of waves that exist in nature. For starters, I'll explain what a wave is. A wave is a disturbance that transfers energy throughout the environment. The energy moves in the direction of the wave. I'll explain this further on when we speak about the types of waves. Now that we have a basic understanding of what a wave is, I'll explain some of the characteristics, the most important being frequency, period, amplitude, wavelength, wave speed, and when comparing two waves, phase difference. First of all, in order to understand two of the characteristics, one must know what a cycle is. A cycle of a wave is the distance between two crests of a wave. I'll now explain the two characteristics I was talking about. One, which is frequency, is the amount of cycles that happen per second. It is measured in hertz, and its unit is second to the minus 1, and its symbol is F. Period is the amount of time it takes for a wave to complete a cycle. Its units are seconds, and its symbol is T. Period is related to frequency, since frequency is equal to 1 over T, or 1 over period. The next characteristic is amplitude, which is the distance between a crest or a valley to the equilibrium point. Its symbol is A, and it is measured in meters. The equilibrium point can be thought of as the x-axis of a graph. The wavelength, on the other hand, is the distance between the crest or valleys of a wave. It's measured in meters and has the symbol lambda, which is the weird sign you can see there. The wave speed is, as the name implies, the speed at which a wave travels. It is measured in meters per second and has the symbol C or V. It is related to wavelength and frequency and period in the following manner. It is the length of the cycle, wavelength, divided by the amount of time it takes for one cycle or period, or in terms of frequency, V is equal to lambda times F. Lastly, phase difference is the distance between two waves with the same frequency and with reference to the same point of the wave. When the phase wave between waves is 360 degrees or 2 pi radians, we can say that they are in phase. However, any other angle can be considered out of phase. Phase difference is measured in degrees or radians. Now that we know the characteristics of a wave, it is time to learn about the types of waves that exist. The two types are longitudinal and transverse waves. As we mentioned before, a wave is a disturbance that transfers or carries energy throughout an environment. So in this case, the longitudinal wave moves parallel to the direction of energy transfer. But what exactly does that mean? Well, think of it this way. A wave is always going somewhere. It can move horizontally, vertically, and even diagonally, whichever direction you want. But a longitudinal wave will always move parallel to that motion, as you can see on the figure right now. On the other hand, a transverse wave will move perpendicular to the direction of energy. So another difference is that one has crests and troughs while the other has a rarefaction and a compression. And as the name implies, a compression is a region of the wave where particles, or in this case, sound waves, come together, while a rarefaction
the disturbance that makes
is a region
up the wave
where they
is along the
apart.
direction in which the wave
Also,
travels.
transverse waves
Longitudinal
can't
waves are
move
also
in
referred to as
liquids and
compression
gases,
waves.
which means that they can only travel in solids and
In a
perhaps on the surface
transverse wave,
of the
the
water.
disturbance that makes up the wave
While
is
longitudinal
perpendicular
waves
to
can
the
travel in
direction
all
in which the
mediums.
wave travels.
Some similarities, however, include that both types of waves carry energy and that they both satisfy the formula V is equal to F times lambda, or frequency times wavelength. Lastly, let's mention some specific examples of each type of wave. Sound waves are defined as a mechanical disturbance, or a wave, traveling through a medium like a solid, liquid, or gas. By that definition, a sound wave is a longitudinal wave. On the other hand, the electromagnetic wave is the travel path of electromagnetic radiation and is produced by the vibration of charged particles. They include magnetic and electric components. In this case, it is a transverse wave. While sound waves are responsible for the travel of sound, electromagnetic waves are responsible for the travel of light. This means that electromagnetic waves can be seen, but sound waves can only be listened to. Unlike sound waves, electromagnetic waves do not need a medium for traveling, and in a vacuum, they travel at the speed of light, which is faster, obviously, than the speed of sound. Another thing is that sound waves only act as waves, while electromagnetic waves can also act as particles. Some similarities include that both waves they both bounce off walls. And the following concepts might be a little bit hard for you to understand right now, but we will cover them on our next video. Those similarities include that both types of waves can be reflected, refracted, diffracted, and that they can interfere. As I said before, we'll cover those concepts on our next video, so stay tuned, and I'll see you on the next video. Thank you.